Okay, so today's lesson is 17.2. This is about the law of sines and area of a triangle. I want to draw your attention to your homework assignment, which is right there. It's out of the textbook. Again, if for some reason the page number is wrong, because my page numbers are different than yours, if the page number is wrong, go to the section in the book. This would be Module 17, Section 2, and that's the homework assignment that you would be working on. So, in today's notes, there are two types of problems we need to do. We need to find the area of a triangle, and we need to use this thing called the law of sines. We're going to start off with area of a triangle, and they actually have the area formula written three different ways. 1/2 BC sine A, 1/2 AC sine B, 1/2 AB sine C. Now, I don't care to memorize all of those formulas. What I like to remember is when you have a part of a triangle, you have two sides that make up an angle. We would call that the included angle. The area is 1/2 of this side times this side times the sine of the angle that is included. It can't be another angle. It has to be the angle that is included between those two sides. So, my first example right here. Here is my angle. It's 141 degrees. That's the obtuse angle. Notice this isn't a right triangle. We can't use SOHCAHTOA or anything on it. But let's see. I'm going to do my area formula. So I'm going to have area equals 1/2 the two sides and then the angle that they make up. So that would be 7 times 7.5 times the sine of 141 degrees. After that, as soon as I get that set up, I just go straight to my calculator and I do 1/2 times 7 times 7.5 times the sine of 141, and I get the area is 16.5, and let's label this. They were talking about inches, so area is always measured in square units. So if I had inches, I need to label it as inches squared. That would be my answer for that problem. So it's pretty easy. You don't really need to memorize the formulas as long as you remember that you have to have two sides and the included angle in order to find the area. So if we look at this one, they give me two angles, but neither of them are an included angle for the two sides that I have. And I can't use Pythagorean theorem unless I know it's a right triangle, and I don't know that in this case. So, if they're giving me this side and this side, the included angle for those two sides would be this, because it's the angle that's made up by those two sides. Do I know the measurement of that angle? Yeah, because I can do 180 degrees minus the 80 degrees I know and the 45 degrees I know. And that will leave me with, let's see, 180 minus 80 minus 45, 55 degrees. So I do know this angle. It's 55 degrees. So I can do my area. I can say that area is 1/2 of the two sides, 10 and 12.9, times the sine of the included angle, which is 55 degrees. So I just go straight to my calculator. 1/2. Oh, there goes my phone. Times, let's see, let me try and silence that. Hang on a minute. Sorry about that. Let's see, 1/2 times 10 times 12.9 times the sine of 55 degrees, and my area is 52.8, and let's label it appropriately. They were talking about yards, so I would have yards squared, square yards. Every time you're talking about area, you always have to talk about it in terms of something squared. Square feet, square inches, square yards, square meters, square kilometers, square miles, etc. Okay. So that's the end of the area problem. Super easy. Just got to remember how to use the formula, and then you just plug it into your calculator. Now we move into this thing called the law of sines. Now, On page 663 of your textbook, they show you how they derived the law of sines. If you're interested in seeing where it came from, go ahead and look on page 663. I'm just going to go ahead. Use any two of these fractions. Each has an angle and its opposite side. So law of sines is really easy to memorize. The sine of A over little a equals the sine of B over little b equals the sine of C over little c. And when we use the law of sines, we use it in triangles that aren't necessarily right triangles. So it's not like we can talk about SOHCAHTOA with opposite over hypotenuse, because there is no hypotenuse in a non-right triangle. So this works in cases where you know two angle measures and any side. So if you have angle, angle, side, or angle, side, angle. It also works when you have two side lengths and the measures of an angle that is not between them. So this one says find EF and the area. I'm going to start off with the area because that's what we just did, and I have two sides and an included angle. So I'm going to go ahead and do the area really quick. That would be 1/2 times the two sides times the sine of the included angle, which is 56 degrees. And when I plug that into my calculator, I have 1/2 times 15 times 20 times the sine of 56. The area is equal to 124.4 miles squared, or square miles. Okay, so I'm done with the area. Now I'm going to use the law of sines to help me find, what do I need to find? EF. So I need to find this side right here. I'm going to go ahead and call this side X. I need to find what X is. So whenever you use law of sines, you want to first look for an angle that you know the measure of and you know the side opposite it. Because I can take the sine of this over the side. So I'm going to say sine of F over little f. That's what I would be doing first. Now I have to talk about, let me use a different color. Now I have to talk about the X. X is a side, and I need to use the angle across from it. Now if X was across from angle E, I would have to find angle E first by subtracting these from 180 and seeing what's left. But that one is given, so I'm going to say sine of D over little d. And now I'm going to plug in my information. The sine of angle F, that would be sine of 47 over little f is 15, is equal to the sine of D, that would be sine of 56 over little d, which I'm calling X. Now how do I set up something when I have a fraction equals another fraction? I cross multiply. So I'm going to have 15 times the sine of 56, that's what I get when I multiply this way, is equal to X times the sine of 47. That's what I get when I multiply this way. So how would I get X by itself? I would divide by sine 47. And now I have some calculator work. So let's see. I don't think I need to, but we'll just do this. 15 sine 56 over sine 47. Now, if your calculator doesn't put it into a fraction like that, you can also type it in this way. You can say 15 sine 56. I don't know if it works out if I don't put this in parentheses, but I'm just going to put all this in parentheses just to be sure. It's always a good idea to start off with it in parentheses like that, and then click divided by sine of 47. So the whole numerator was in parentheses there. And I get 17.0, which I'm going to call 17. And specifically, since we're talking about miles, I'm going to call it 17 miles. So this will help because at this point they could ask me to solve a triangle that's not a right triangle, and using the law of sines I can find missing sides, whereas if I had a right triangle I was able to use Pythagorean theorem or SOHCAHTOA to find missing sides. Here I have to use the law of sines. So again, the law of sines is sine of the angle over its opposite side. Sine of the angle over its opposite side, sine of the angle over its opposite side. And you pick any of these two. So if you have this one and this one, you would set sine A over A equal to sine C over C. If you have B and C, you would set up those two fractions. Whatever you have to set up two fractions so that you can cross multiply. So let's get down to this last problem. It says solve the triangle. So I know 3 sides. I believe it's cut off my paper, but this is actually 17. The one that just happened to be right in the hole punch there. So this is 17 centimeters. This is 30 and this is 35. Now, you can come to an issue sometimes. It's not really an issue with you. It's an issue with your calculator. When you are trying to find an angle that's very close to 90 degrees, sometimes your calculator will round off kind of funky. So when I look at this triangle, one of these angles that I'm trying to find, angle K, looks kind of like it could be close to 90 degrees. You see that? It could be 89, it could be 95. Anywhere between 80 and 100, I would find that angle last. So instead of doing K, I'm going to do H. So try and avoid ones that look kind of like a right angle just to avoid that calculator thing. So I'm going to start off with H. And I'm going to find that by using my law of sines. So I'm going to use 17 and H because that's the side opposite that angle. So I'm going to say sine of H over what little h is, and that's 17. And I'm going to set it equal to, I need another angle and its opposing side, or its opposite side. So again, I can do those guys right there. Again, I'm not going to choose K because since I already have something that's not known, I need to know both parts of this fraction. If I don't know a part of this fraction and I don't know a part of this fraction, I'm in trouble. I need to know at least one part of, or I need to at least know both parts of one of the fractions. So over here, I can put sine of 59 degrees over 30. Now this one's a little different. The last one I was looking for a side. This one I'm looking for an angle. So I'm going to cross multiply 30 times the sine of H. That's what I get here, is equal to 17 times the sine of 59 degrees. Now, I can't get H by itself, but I can get sine of H by itself. And I can do that by dividing by 30. So sine of H is equal to this whole ugly thing. 17 sine 59 over 30. So if I, oops, sorry, that's 30, not 3. So if I plug that whole thing into my calculator, again, I'm going to put parentheses around the entire numerator just because I'm not sure about that 17. I want to make sure that they keep it on the numerator for me. 17 sine 59, I have to close 2 sets of parentheses there, divided by 30, and I get 0.485. And again, my phone's ringing. Don't know who it is. Okay, so sine H is equal to 0.485 blah blah blah. So how do I find the angle if I know what the sine is? Let me turn that down so it's less. There we go. So the sine of H is equal to that. So this is where I'm going to use that inverse sine to find what H is. That's the sine to the -1 of that ugly decimal. So again, I rounded it off just because I don't want to take the time to write the whole decimal, but when I plug it into my calculator, I'm going to use that answer button to get the whole thing. So I'm going to do shift and then sine, or second and then sine, and that's going to get you your inverse sine notation. You can see it there, sine to the negative first. And then I'm going to use the previous answer button rather than typing that in because that'll give me a more accurate answer. So angle H is 29.1 degrees. So angle H is 29.1 degrees. So if I talk about solving this triangle, I need to know 6 things. I need to know angle K, angle P, and angle H. And I need to know little k, little p, and little h. So things that were given to me, little p is 30, little h is 17, Little k is 35. And then angle P is 59 degrees. I just found angle H, which is 29.1 degrees. And then to find that third one, I subtracted all from 180. So 180 minus 59 degrees minus 29.1 degrees leaves 91.9 degrees for that angle K. And see, I thought it was close to 90 degrees. That's pretty close to 90 degrees. So that one might have caused some trouble if I had tried to find that one first. Just because our calculators start freaking out with the whole sine value of 90 degrees being 1, it just gets messy. So try and avoid those ones and find that third angle by finding the other one first and then subtracting from 180. Okay? Again, your homework assignment right there. It is due tomorrow, Thursday.